30 seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
Producer. All right, we got fixed sound now. Are we good? All right. Audio should be okay now, guys. Once again, very sorry about that. And yeah, it's audio is the Achilles heel of this channel and has been from the beginning. So in any event, really apologize for that. But in any event, yeah, it's interesting what's going to happen, and not too many people are immediately aware of the importance of this. By the way, I'm in a hotel room in Colorado Springs. I've been here for a little while, ever since my producer went home. I'd had to go home in an emergency situation because of the situation with his son, put him on a flight to London in Houston. Then I traveled to Austin to visit my daughter. And then from there, I went to, oh boy, somewhere in Texas, some town in Texas is sort of an in-between stop. And then to Colorado Springs, which is where I'm from originally. Thank you so much. Robert, really appreciate that. Also known as Airborne Bob, a $25 super chat. Man, that's a big help to me now, because this February has been an absolute disaster for traditional YouTube stuff. Traditional YouTube monetization and all that sort of thing has just been really, really awful. So I really, really appreciate that. Thank you very, very much. Okay, so let's go ahead. Thank you. We got another super chat come in from Ride the Liger, I guess. Thank you for everything as well. So really, really appreciate that. So real quick, I want to, first of all, address what has just happened at NASA in case you are unaware of it. Believe it or not, NASA's been talking about doing this for quite some time. Okay. NASA has been discussing the possibility of not going to the moon with Artemis 3 for years. It's all been behind the scenes, but the idea was that the human landing system was not going to be ready to put humans on the moon anytime soon. And it was going to be a good idea to practice docking between HLS and Orion anyway. So the idea of doing an Artemis mission in orbit, which is similar to actually an Apollo mission that accomplished the same thing. By the way, that Apollo mission is used by moon landing deniers as a I don't know, as one of their keystones for their argument, because they have proof, so to speak, of an Apollo module, the LEM, and everything else being in orbit, Earth orbit, not going to the moon. But that was a legitimate Apollo mission that did that in order to practice LEM maneuverability, Apollo maneuverability, docking the two together. And so that is what NASA is planning to do now, which is not a bad idea. Jared Isaacman is finally actually doing this. And so Artemis 3, as near as we can tell, is going to be docking with either one or both of the HLS solutions, according to him, next year. Now, theoretically, that might be possible. That might be possible for Lunar Starship, given the fact that Lunar Starship has, been going at least into suborbital space and probably could have made it to orbit if that was ever part of the flight plan. So Starship might be able to do that and conduct a docking exercise. But then again, NASA isn't going to want to do that with Lunar Starship until it's proven itself to be very maneuverable in orbit, until it's actually docked with another Starship, done a refueling test, that sort of thing. So that will probably happen with Starship. However, as far as the Blue Origin solution, it really depends on what they're planning on doing. If they're going to do a modified Blue Moon Mark 1 for now, just to get something operational as quickly as possible, or the Blue Moon Mark 2, I don't see how that's going to be ready to even do docking maneuvers next year. I don't see how that's even remotely possible. And then, according to Jared Isaacman, the objective is to increase the manufacturing speed of SLS to where SLS can actually carry out 2 launches in 1 year. That's the idea anyway. And so the idea is to do not 1, but 2 lunar landings in 2028. I'm going to do a video tomorrow detailing why that is, although that sounds great. There's just too many problems with that idea for it to be realistic. I mean, I'm sure that Jared Isaacman wants to see that happen in 2028 in order to satisfy his boss, because Trump obviously wants to see a lunar landing in 2028, and I don't think he would have been happy with any other solution. But that being the case, yeah, I don't know. We will see what ends up happening with all of that. But now, at this point, let's talk real quick before Rocket Lab goes live anyway on their current launch as to what's going on here. This is a launch of what's called the HASTE system. It's an Electron rocket, essentially the mainstay, the only operational rocket that Rocket Lab has currently. The HASTE is designed for hypersonic test articles, and up to now, it has only ever been used. It has only ever been used for military purposes, for military experiments, military hypersonic experiments. But for the first time, it's going to be a commercial flight on the part of a company called Hypersonics, appropriately enough. And what Hypersonics is doing is they are designing a hypersonic space plane. I interviewed them 2 years ago at Space Symposium in Colorado Springs. They're an Australian space plane company. By the way, Anton Nim, thank you so much. Really, really appreciate it. Ben Solo, it'd be great to bring back the Alpaca, but I don't see how that's going to happen at this point. Alpaca was designed by people at Dynetics, virtually all of whom no longer work there. I've tried to reach out to them over the last year and a half or so, and very few of them are even still at the company because there's no purpose for them being there. Dynetics doesn't have a human-rated program anymore. So depressing, but unfortunately, that's the reality of the situation with Alpaca. So this HASTE vehicle is going to launch a hypersonic test article for this Australian Hypersonics company. We don't know a lot of the other details. We're just going to have a main engine cutoff of the booster stage, of the first stage of the Electron rocket, and then whatever this thing is going to engage at that point. And we don't even know exactly how much of it we're going to be able to see, how much of the test article in operation we're going to be able to see, assuming the test article goes anywhere at all, assuming that, I mean, this is the first test of this vehicle. So who knows? The thing might just blow up. It might not go anywhere, or it might do something very impressive. We don't know. And that's what makes all of this so very exciting. But what's really intriguing about this is you have a New Zealand launch provider, even though this is launching from Wallops Island in the United States, and officially Rocket Lab is based out of the U.S. in order to get those nice U.S. military contracts. But for all practical purposes, the vast majority of the staff are New Zealanders, and an Australian hypersonic company working together for something very, very impressive indeed. So yeah, that interesting, Mad Professor, what you've had to say about that. And I would say that that's very possible. It's very possible that the SLS Block 1B, the SLS Block 2 may no longer be something that NASA is going to work on. They may simply push forward with SLS as it is, with the sole objective of getting the Orion out to cis lunar space, and no further than that. If that is indeed the case, if Block 1B and Block 2 have been canceled, in many ways that simplifies matters, and that might be a good thing in some ways, but in other ways it's a real problem, because the new launch tower, the ML2 launch tower, was designed for SLS Block 1B. So either you're going to have to build another new launch tower for the basic SLS to do more SLS launches, or you're just going to keep using this original ML1 launch tower for launch after launch of the SLS, which would be a terrible idea if that's what they have in mind. Because this thing is a piece of garbage. And I've said that many times. It's poorly designed by multiple contractors who did not communicate with one another. It was a really, really disastrous project. ML2 has been under construction under much better circumstances. But ML2 and all of the umbilicals, everything on the launch tower is designed for the SLS Block 1B, not for the basic SLS. Now, we'll see, because the upgraded solid rocket booster program is not necessary for SLS Block 1B entirely. It could be the SLS Block 1B, the major modification with that rocket is the EUS, the exploration upper stage, that has 4 engines, 4 RL-10 engines instead of just 1. It could be that canceling the upgraded solid rocket boosters for SLS may just be shutting down Block 2 more so than shutting down Block 1B. SLS with the exploration upper stage, it still has substantial improvements in its capability, very substantial improvements in capability versus the current model. But then again, once again, I don't know all of the official announcements. All I've seen is Jared Isaacman's official speech that he's made right now. I'm sure there's a lot more news on that, but if the idea is to shut down Block 1B completely, as I said, that is going to be problematic as well. It really is, because the whole launch tower is being built for Block 1B. You can't just change that on the fly. And what do? You keep the old launch tower. That thing has been one of the biggest sources of problems for SLS the whole time. It is a cobbled together piece of garbage and just a very, very bad idea, in my opinion, to keep using that old launch tower. So I don't know. It's all very ugly news for the most part, but at the same time, I think Jared Isaacman is doing the right thing in terms of trying to make Artemis more like Apollo. Artemis, as it stood, was a really, really flawed program because the idea was one unmanned launch, one launch to orbit the moon, and then the third launch to land on the moon. That really is setting yourself up for failure. Only 3 launches to get you to the moon. Let's compare that to what happened with Apollo, with double-digit launches of Saturn 1, followed up by 9 launches of the Saturn 1A, I think it was. They had the upgraded version of Saturn 1, then 2 unmanned launches of Saturn 5, then Apollo 1 getting destroyed on the pad, astronauts dying there, which of course was a terrible thing to have happen. But it happened in spite of all of those test flights. You still had astronauts getting killed. Can you imagine the risk that you'd be taking without test flights and trying to land on the moon? The odds of astronauts being killed under those circumstances, I would say that I would say that be much, much more dangerous for just a lot more dangerous for this situation. I'm going to go ahead and try to adjust my camera a little bit and see if that helps at all. Bear with me for just a moment. I'm trying to make some adjustments. Maybe that'll help. I don't know. Maybe it won't. I might have just made it worse. But once again, that's Artemis. I'm releasing a video about the topic, about how it is an improvement in many ways. It's a good idea in many ways to have increased SLS production and more test flights, more Artemis test flights, so to speak, before we actually try to land on the moon, as we did with Apollo. I think that that's a very good idea. But on the other side of the equation, a truly disastrous, well, not disastrous, but an unrealistic expectation that we're going to be able to put human landers, the HLS, on the moon, not once, but twice in 2028. As Mr. Isaacman explained, I don't see how that's even remotely possible. So all that being the case, again, back to this Electron launch today. Very exciting. Really a lot of good news, even though, by the way, Rocket Lab will be going live in about 3 minutes, just so you folks know. So we'll go ahead and bring them on for you. I'm sure there'll be copyrighted music and such through all of that. But once again, to reiterate, they're using the HASTE test article that's designed for suborbital hypersonic flight. This will not be going to orbit. That's not the purpose of this flight. The HASTE is designed to be used for suborbital hypersonic test articles. Most of the time, it's being used for hypersonic missiles. The U.S. military, U.S. Space Force has been testing hypersonic vehicles with the objective of eventually building hypersonic missiles, and the HASTE has been a rocket that's enabled that capability. It's been a very, very lucrative contract for Rocket Lab thus far. And this is what Hypersonics in Australia recognized, was that since Rocket Lab was doing this suborbital hypersonic test flights anyway, that would be an ideal rocket for them to use in order to launch their own test article, which once again is a hypersonic space plane with the objective of perhaps taking passengers to the other side of the world in an hour or less. Again, landing on traditional airfields rather than a huge spaceport as Starship had in mind in SpaceX. And also achieving a high enough altitude to where it could theoretically launch launch satellites or perhaps even human-rated spacecraft into orbit, and a 100% reusable design is the idea behind this. It's essentially an SSTO, single stage takeoff. But again, this single stage SSTOs have been notoriously difficult to design and build over the years, but this is going to be an interesting attempt to make this happen today. And let's really, I've got high hopes for this. I really hope that something good comes out of this. Of course, it is the first test flight, so the first test flight is probably going to end in disaster. But at the same time, that's, just not the objective. What would really be a disaster here for hypersonics is if something goes wrong with the Electron, something goes wrong with haste before it even gets to the point to where the test article is separates from the booster stage. If that were to happen, then they don't even get an opportunity to test their hypersonic test article, which would be very, very bad indeed. But Rocket Lab has a very high level of reliability right now. They haven't had an anomaly in quite some time, well over a year. I think we're pushing at least 2 years since their last anomaly. But I'll tell you, I have a history of jinxing rocket companies. I've had a lot of flights go bad on my live streams. I have no idea how or why, but they just have. It's very bizarre. But in any event, fingers crossed. Let's hope for the best for Rocket Lab and Hypersonics today. We're getting very, very close to Rocket Lab going live. This should be very interesting. Like I say, these sorts of things don't happen every day. They don't happen very often at all, actually, unless it's a military test flight with a hypersonic missile of some kind. This sort of thing is extremely unusual. So it should be intriguing. I hope we get to see some of it. I hope there's cameras installed on the test article or on the booster, something along those lines, to where we'll get an opportunity to get a look at it in operation. But at the same time, Hypersonics, the company that has the test article, they may want to be secretive. They may want to hide their technology from competitors, that sort of thing. So can't say that with a certainty that's going to go. It's going to go that way. But fingers crossed. We'll see what Rocket Lab ends up doing. Yes, go ahead. Well, how about that? Aztec, one of my team members, Aztec, is actually in a position to where he may be able to see the rocket in flight because he can see Wallops Island from where he is currently. We are going to attempt to bring you a camera feed from there. Once again, I'm not making any promises. It could be very, very difficult to make that happen. But fingers crossed, we will see. Yeah, I'd say it's a good chance of that. Aztec, go ahead. Yeah, we'll see if we can. We'll see if we can bring you a camera feed from out there. It's about 30 miles, 50 kilometers away from the launch, but we will see. And by the way, as far as SSTO is concerned, this is a test. This is just getting essentially the part of the space plane that engages the engines that operate in the upper atmosphere into the proper position, instead of having it take off from an airfield. The takeoff from the tarmac is something that happens later in the development process. The whole objective here is to get the space plane into the upper atmosphere to where it can engage its hypersonic engines and such and test its capabilities in the upper atmosphere. Rocket Lab is essentially doing the first part of what eventually the plane will theoretically do on its own. That's the idea behind that. Dream Chaser Tenacity, Matt Professor, I thought that Sierra Space Dream Chaser was had just about had it. I hadn't heard a whole lot else about it, and then all of a sudden they release some footage of them doing a drag test across the landing, the old space shuttle landing facility at Cape Canaveral, which is one of the things they do just prior to launching the thing. So they're still working on it. Apparently, they haven't given up. So we'll see as far as that's concerned. Rocket Lab Neutron is now not expected to fly until the end of this year. Again, that should surprise no one. Something that sophisticated is going to run into problems. It's as simple as that. But it's not critical to Rocket Lab's success to have Neutron work. It'll catapult them into a different world of competition if Neutron works. But right now, everything the Rocket Lab is currently doing in terms of satellite design and spacecraft design, and of course the Electron and everything they do with that has made them into a very successful company. Everybody is focusing on Neutron as if that's the make or break for Rocket Lab, but it really isn't. Even if Neutron takes a couple of test flights to get operational and all that before it's actually carrying cargoes, even if it's 2027 or even later for them to actually start taking up heavier cargoes, it's not necessary for Rocket Lab to rely on Neutron. They have a very successful business model with what they have now. I've continued to get questions about Artemis 3. I talked about it at the beginning of the broadcast. I'm going to be doing a video about it. I think it's very sensible in some ways and absurd in others. The sensible side is the idea of getting SLS up to speed. Okay, I think we need to take the fundraiser thing off of there, producer. And you may have already done it. I don't know. That's from a previous live stream. By the way, we achieved that and exceeded it tremendously to get producer out to the United States. Thank you so much for that. Really, really appreciate what you guys did in making all of that happen, which simply wouldn't have happened without you. And even though we didn't cover the launch, we did get a lot of footage from Houston and Cape Canaveral NASA facilities. And in addition to that, we have enough funds to where we'll be able to bring him back for another launch attempt. So I'm very, very excited about all of that. So once again, waiting for Rocket Lab to go live. This should be interesting. It's this sort of thing doesn't really happen. The problem with here we go. Yep. Okay. Let me know when the music's over. Okay. We have the footage live right now from Rocket Lab. I'm waiting for the copyright music to go away. Got some exciting stuff coming, folks. It should be very interesting. Very interesting what happens today.
The board for our HASTE rocket, the payload, and the range here at NASA's Wallops Flight Facility.
All right, audio's hot.
Today
Let's
we'll
go.
be taking the DIU's next experimental hypersonic mission to the skies to deploy DART-AE, a scramjet-powered aircraft developed by Australian aerospace engineering firm Hypersonix with an X, and with a nod to their payload and Australia's classic cultural icon Crocodile Dundee, we are calling this launch That's Not a Knife.
Today's mission marks the historic first flight of DART-AE, which will be used to validate the aircraft's propulsion, materials, sensors, and guidance technology under real hypersonic flight conditions. At the heart of DART's 3D printed airframe is its scramjet engine, an air-breathing system similar to that of a jet engine. Now it uses oxygen in the atmosphere to combust with fuel, generating the thrust needed to fly at hypersonic speeds. This innovative design is part of Hypersonics' mission to create a low-cost, multi-mission hypersonic aircraft for applications in defense, aviation, and aerospace. And now, here's more from Hypersonics about DART AE.
The time is right for hypersonics.
All right. Then we have more copyrighted music, unfortunately. One thing, a comment was made about how Electron looks the same as always. It actually doesn't. If you look at the fairing, you're going to see that that is the biggest fairing that Electron has ever had installed. It is a very long extended fairing compared to anything else that it's ever done or anything that it's ever had in the past. And just to let you know, the cargo on board this rocket is so heavy that there is no way that it would be able to take this thing to orbit. This is a suborbital cargo. Okay, we still have copyright music going, don't we? Yeah, we still got copyright music, unfortunately. So again, testing these scramjet engines should be an amazing thing. I wasn't entirely certain as to whether or not they were going to do all that. So yeah, I mean, it looks like a pretty ambitious test flight that's going to be going on here. We'll see what ends up happening. We'll see just how successful it is. But still, yeah, this is ambitious. And once again, the launch is going to look different too. It's going to be going to a much lower trajectory, which means the rocket will remain visible far longer as it follows the curvature of the Earth in suborbital space rather than heading to orbit to deploy a satellite. So the people who are there at Wallops Island, and by the way, I wish I was there. That's one of the launches I would have liked to have seen. They're probably going to get an interesting show. By the way, we are still in the process of seeing if we can bring you a camera view of the launch itself. It's going to be quite a distance away, so we might not be able to see much of it. But nevertheless, we do have a team member who's approximately 45, 50 kilometers away from Wallops Island, which is definitely close enough to see the rocket, the plume anyway, in flight. And who knows, might even catch the plume of this hypersonic DART test article from Hypersonics in flight. By the way, as I said, I interviewed these folks in 2023 and at Space Symposium right here in Colorado Springs. And I did not imagine that they would make this much progress this fast. They really didn't seem like they were that big and have that much capability. But you know what? It's kind of cool because they do. Let's go ahead and bring Rocket Lab back.
Technology online for the United States and its allies.
And they won't have to wait much longer to see DART AE leave the launch pad for its first ever flight, now that we are just T-minus 17 minutes in the countdown to liftoff. At T-minus 16 minutes, our teams will enter into the go, no-go poll for today's launch from our Mission Control Center in Virginia. This is the final readiness check that takes place before liftoff, where the launch director will ask each team member for a clear go or no-go to proceed. One by one, responsible team members will confirm that their systems are working as they should and that there are no concerns leading up to the final count.
If everyone reports go, then Rocket Lab's launch director, Paula Terrace-Serralonga, will confirm that we will proceed through the final minutes and then on to liftoff. That poll is about to begin, so let's listen in now.
How did you get there?
GC LD.
Umbilical and arm and prime sequence complete.
Thank you. And to all stations, LD on count
Okay,
and
they're
proceeding
up
with
to
the
the
final
go, no
call for
go.
launch. Go, no go sequence, starting with the stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Vicon.
Vicon is go.
GC.
GC is go.
PLS.
POS is go.
Mars CE.
Mars CE is go.
Mars Ops.
Mars Ops is go.
Was quite quiet, Mars Ops, Mars 1.
Mars 1 is go.
And continue with NASA GSO.
GSO go.
NASA RSO.
So is go.
NASA PM.
Go.
LD SAP.
LD sub is go.
NASA TD.
Go.
Can you just repeat TD, please?
TD is go.
Understood, TD. We'll be standing by for final go for mission director Paul.
Beautiful. That was a clean series of goes across our team, pending the mission director's go as well. Otherwise, we are on track with today's launch attempt at 4:50 p.m. Eastern Time. Now, if anything changes, we have a couple of hours into the rest of the afternoon to reset that clock for another attempt.
Now, earlier in the count, we checked in with the team at Launch Complex 2 on Wallops Island as they conducted vehicle checkouts on haste, ensuring everything was ready before the vehicle was raised vertical on the pad. Now, our range coordinator, David Stiles, is here to take us through what's involved in those early launch operations.
Good morning. On this glorious day here at Wallops Island, I'm David Stiles, the range coordinator for Rocket Lab here on the eastern shore of Virginia. And directly behind me is our HASTE rocket on the pad at Launch Complex 2 within the Mid-Atlantic Regional Spaceport. The team behind me are getting ready to go for our latest hypersonic test launch for the DIU. It's a crisp 40 degrees out here at the pad, where our launch technicians run through a full day of launch operations before liftoff. Starting from about T-minus 9 hours, we work through general pad system setup before we connect HASTE Stage 1 umbilical. That's the critical power line that connects the rocket to our ground support system all the way up until just before liftoff. At the same time, just a few miles down the road, our launch operators check in to their consoles in our Mission Control Center. Once those early checkouts are complete, the team takes HASTE vertical just a couple of hours later and run an igniter test sequence of the Rutherford engines, making sure the propulsion system is fully primed and ready for the launch ahead. In the hours that follow, the team load the rocket with its kerosene propellant, as well as run checks across our ground stations and avionics before we get into the lock system chill and load sequence at around 3 hours before launch. The range safety status comes in around 60 minutes and T-minus 30 minutes before launch. And then we move into the go, no-go poll with the launch director at T-minus 16 minutes in the count. It's a full-on run of operations here at LC2 with a busy team both down at the pad and at their consoles. And keeping busy right next door to LC2 is our Neutron team working on Launch Complex 3. LC3 is our new launch test and landing site for our much bigger reusable rocket on the horizon. While we officially opened up that site last year, you might notice a new structure mounted to the top. That's the test tower for Neutron's second stage. Our engineers and technicians are also working through infrastructure and fluid systems commissioning, including cryo-shocking the 3 15,000-gallon liquid nitrogen tanks we have on site and the pair of 90,000-gallon liquid oxygen tanks that make up the tank farm. It's been really fantastic to watch it all come together while Electron and HASTE launch operations carry on right next door. It's a beautiful day to launch another rocket from LC2. I know everyone here is super excited to watch another HASTE mission fly. Go HASTE and go Rocket Lab.
And here we are now, T minus 10 minutes or so on the clock, almost ready for launch with our second flight from Wallops Island for the DIU in just a matter of months.
As we count down to the launch of That's Not a Knife, here's more about our HASTE rocket flying today's mission. HASTE is an acronym that stands for Hypersonic Accelerator Suborbital Test Electron. And while it does look a lot like our usual Electron rocket, there are a few key differences that make it the perfect platform for experimental hypersonic test flights, just like today's mission. For a standard orbital launch, Electron achieves orbital velocity to deploy payloads above the Kármán line, which is over 100 kilometers above Earth, before continuing onward to orbit. Our suborbital rocket HASTE, on the other hand, operates in a similar way but achieves slightly lower velocities and altitudes to allow us to test technologies at hypersonic speeds closer to the ground.
Now, hypersonic velocities are anything above Mach 5, or 5 times the speed of sound, compared to, for example, a commercial airliner that flies subsonic, which is slower than the speed of sound. Then you've got supersonic, which is the range above subsonic all the way up to Mach 5. Now, above Mach 5, those are speeds faster than the fastest fighter jet you know about. And then there is our HASTE vehicle, which flies well beyond that and is capable of velocities all the way up to Mach 20.
Now that opens up a range of test capabilities for mission partners like the DIU and Hypersonics, where thermal properties, tracking and control can be tested in real hypersonic flight environments, which can't be replicated on the ground. And that's exactly what today's experiment is all about. After it launches off the pad, our HASTE rocket will boost DART-AE to hypersonic speeds before it's released horizontally to free fly on its own under aerodynamic control and scramjet propulsion.
Now, HASTE's out-of-the-box hypersonic capability is being well leveraged for higher cadence and more affordable hypersonic test flights. And today's launch is our 4th hypersonic test mission in under 6 months from LC2, which is exactly addressing the needs of what the US government is looking for, with more frequent and reliable flight opportunities to develop hypersonic capabilities. So here's more about HASTE.
The world is accelerating, and so are the threats we face. Escalating geopolitical tension has revealed a critical defense capability gap, a challenge defined by Mach 5 and beyond, the speed of hypersonics.
Copyright music just came on. So just to answer the questions, yeah, it looks like some folks are visiting us late. This is not Rocket Lab's hypersonic test article. Just to be clear, the HASTE, as you heard in that explanation, is a rocket designed to launch a hypersonic test article into suborbital space. And it's done that a number of times for the military. This is the first civilian commercial hypersonic launch that Rocket Lab has assisted with. And really, there have not been very many of these at all, period. And this is a scramjet that will have to be, it's an air breathing engine. So that means it will be launched into the upper atmosphere. It will not make it all the way out into space. And then it will engage its engines at that point and essentially test its aerodynamic capabilities and test its test the engines, obviously, that sort of thing. This is the first ever flight attempt for this test article, so we shouldn't have too many huge expectations for this, given the fact that Hypersonics is a small private company, spaceflight company in Australia. But nevertheless, if they pull off a really impressive flight here, that would be an incredible thing to see. But if the thing manages to separate, if it manages to fire up its engines, if any of that happens, that's still a good move forward for what they're attempting to do here. Because this is a company that, like so many of these startup spaceflight companies these days, they operate very much like SpaceX. They don't have the money to test every component to failure, spend years and years developing the perfect rocket that's going to be successful on the first flight or anything like that. Instead, what this is going to do is it's just going to be a test of the engines, test of the aerodynamic qualities of the vehicle. So we'll see just how good of a flight this is. But yeah, all that happens with HASTE is it propels it's a test article into suborbital space, usually in the atmosphere. That's what it's done for hypersonic missiles for the military. But this is a great opportunity because it's a commercial hypersonic launch, and it could be that we're going to see a lot more of this flight than what the military would show us. I think we're going to see a lot more of a hypersonic test flight than maybe we have ever seen before, period. Because keep in mind, vehicles like, for example, the Virgin Galactic Spaceship 2, that only achieves speeds of Mach 3 or so, not hypersonic. So this is taking a space plane to a totally different level. And again, being scramjet engines, definitely air breathing. The idea, I think, is for these engines to transition over to rocket engines later on, or to have separate rocket engines, take it up into space in the future. But right now, they're testing the scramjet capabilities. And even in suborbital space in the atmosphere, this thing could carry a satellite, a satellite could be launched from the hypersonic plane into orbit. By the way, we now have our camera operator. Thank you so much, Mike. I'll tell you, above and beyond, he's going to try to show us this launch from his vantage point, approximately 45 kilometers away from Wallops Island. No guarantees, guys. May not be able to see much, but fingers crossed, we'll show you all we can. Let's bring back Rocket Lab.
And we won't hear it across the nets from Mission Control either, but we will stay live on air through those mission milestones to call out when those actions are expected to happen in real time. And all in all, we are expecting just over 2.5 minutes of flight time to boost HASTE to hypersonic speed. And then it is over to DART to carry out its mission objectives for hypersonics in the DIU.
It's going to be fast and exciting to experience in real time. But first, we have to enter the launch's countdown auto sequence, which starts at T-minus 2 minutes to liftoff. At that point, the HASTE rocket will switch to internal power and take over control of the countdown. At the same time, its launch safety system will be enabled, and Mission Control will call out both of these actions across the nets. A few moments later, the rocket's liquid oxygen propellant loading should be complete. And that's another milestone we can expect to hear from Mission Control.
At under 1 minute to lift off, the propellant tanks will be at their optimum pressure levels for launch. Ground control will then confirm that the water deluge system on the pad is ready to be activated for when those engines on the rocket ignite. Then we get a 30-second notice to launch before the launch director counts down with the clock from T-minus 10 seconds. The engines will ignite at T-minus 3 seconds, and the launch pad's hold-down mechanisms will be released for HASTE to take flight at T0.
All right, guys, it's coming up.
Okay, taking a look at the clock on the top left-hand screen there, we've got a pause in that countdown. So we're going to bring up the audio channels from Mission Control and have a listen.
Main engine cut off and...
LD avionics.
Avionics, proceed with avionics terminal abort checks, sequence 73.
Copy sequence 73.
Here's our pause.
And
no shot, no shock there.
LD stage.
Stage, proceed with the terminal abort checks, sequence 74.
Copy, Mark.
Control station LD on countdown. While the operators are working on their terminal abort checks, we'll be working on the recycle sequence.
Vehicles on external power.
We've entered a hold at T-minus 3 minutes for upper-level winds, which we knew was a possibility for today's mission. So let's listen in to see if the clock can be reset soon.
We've got wind issues. And we've got a guy out there right now telling us that it is indeed windy where he's watching this from. So we'll see if we can have a recycle of the countdown or if this is going to be a scrub. Is currently located. Other people are apparently hearing about this launch. I'm sorry, go ahead. ASN, I didn't hear that. Okay. We have another issue with, bear with us for just a second. We're waiting to get updates on what's going on. Yeah, you're right. There doesn't seem to be a lot of wind affecting the venting. This is upper level winds that's been reported. And yeah, and so they have copyrighted music playing right now. As you can see, you may have had an opportunity to see that from the camera that we have in the upper right. There are an unusual number of vehicles that have gathered, although some of them may be leaving now that there's a possible recycling of the clock. Perhaps a scrub, we'll see. Can't say for certain that there's going to be a scrub, obviously. Fingers crossed. So we'll see what ends up happening here. Right now, it just could be temporary wind issues. But again, we want to make sure that this test article gets separated in ideal conditions. You don't want something as petty as wind messing up the test. You definitely want to see a test under ideal circumstances if possible. So fingers crossed. Let's hope that the weather conditions improve. The upper atmosphere or the upper altitude winds that seem to be sabotaging the launch at the moment. Let's hope that we don't have any further issues. Again, to update you folks on the things that have been happening with Artemis, an announcement has been made that Artemis 3 will not land on the moon. That is not the objective. There's been talk for a long time, to be honest, about the idea of Artemis 3 being repurposed into a human landing system rendezvous flight to send Orion into orbit, have it rendezvous with the HLS in order to practice that docking. It's always going to be a very bad idea in many ways to go straight from an orbital test with no docking to a docking attempt in lunar orbit. A lot of people thought that that was a real serious risk. But the problem is SLS takes so long to build and it's so damned expensive that the idea of launching SLS over and over again just didn't seem like a great idea. However, that being said, if Jared gets what he wants and works SLS up to a rapid manufacturing design cadence, then that could change things rapidly. That could really that could change how much it costs, for one thing. And Jared Isaacman talks a lot about changing the manufacturing staff, changing the manufacturing plans and procedures for SLS. So under his guidance, it could be that SLS becomes a much less expensive vehicle. We'll see. But even though I think that's a good idea for SLS to fix the problem with that, the problem isn't just with SLS. The problem is getting the human landing systems ready to land on the moon. And frankly, I don't see how either Starship or the Blue Origin Mark II are going to be ready for lunar landings. that quickly. I really don't see that happening by 2028. And I don't know how he's going to change that to take a vehicle that's still in development, both Lunar, Starship, and Blue Moon, take those vehicles that are still in development, have yet to achieve their critical design reviews. They haven't even gotten those yet. How do you get a vehicle that hasn't gone from critical design review to a human rated vehicle capable of landing on the moon in 2028? It really doesn't seem possible. What might be more feasible, as I mentioned before, is a modified Blue Moon Mark One. But if they're going to do that, they need to have been working on that for quite some time. And who knows, maybe Blue Origin has been doing that. They are very secretive. So maybe we'll see what ends up happening. If ESA can build 12 Ariane 6 rockets a year, then Jared can build 2 SLSs a year. Yeah, I think so. But there are problems. The side-by-side manufacturing, building multiple rockets simultaneously is the way they built Saturn V's rapidly for a rapid cadence back in the day. And they don't have those manufacturing facilities anymore. They have enough manufacturing facilities to build one rocket at a time. Okay, we got Rocket Lab back. No, we don't. I thought we did, and then we don't. Okay, so we're still waiting to see whether or not they're going to recycle that clock. We will see. We will see. Oh, by the way, Double Ed, you're right. And I'll never deny that. I'll never deny that. SpaceX has definitely transformed the spaceflight industry. Falcon 9 has achieved things that no rocket ever has, and probably no rocket ever will. That the cadence that Falcon 9 has, the amount of times that you can reuse that booster over and over and over and over again, the way they do it, it is an astonishing rocket. And yeah, I don't see how anything will ever be able to match its capabilities. Maybe Starship can, but we aren't seeing that yet. Maybe someday, but we're getting there. All right, so we're losing our camera temporarily until we get closer to launch, assuming that we recycle the clock and a launch actually happens, which we have no guarantee of that. It's cold weather out there in Virginia, and so our camera guy, who by the way volunteered his time at the last second to try to capture this launch, it's very super grateful to Aztec, the awesome Aztec, for doing that for us. So in any event, looking forward to bringing this back up. All right. Now we get these tiny little blurbs. Get these tiny little blurbs, but nothing else. I'm waiting to see what they're saying. All right, so we didn't get to see those upper level winds graphic. I think that the graphic that he was speaking of was for the benefit of the Rocket Lab team and not for us. So apparently, okay. All right, so I'm sorry, guys. Let me give you an update of what just happened with Rocket Lab. Whoever handles weather issues for Rocket Lab just talked to the Rocket Lab staff and apparently shared a weather map showing the projected wind speeds over the next couple of hours. Apparently, the wind speeds are going to drop steadily for a while until they jump back up. These are wind speeds at approximately the 40,000 foot level, approximately 12,000 meters or so. And so those are going to continue to drop off, and a possibility for launch still exists. So we're going to stay right here with you as this process continues, and let's hope that that the winds continue to drop off, and Rocket Lab considers it to be safe enough to go ahead and give it a shot. But apparently this is going to be a gradual and steady drop off. That being the case, then it could be a while before Rocket Lab chooses to launch, simply because they do have a launch window of a couple of hours. Which means that if they need to use those 2 hours for the wind to keep dropping off, that's probably what they're going to do. So we'll see. We'll see what they end up doing. But they, as I say, they have about a launch window of approximately a couple more hours, taking us up to about midnight UK time. So we'll see how that goes. It's again always uncertain. Thank you so much, Antonym. Thank you so much for your support. I really, really appreciate it. It makes a very, very big difference. Any super chat really has a big impact on my ability to do things on this channel. So thank you so much. All right. So things we continue to wait, as is the case with Spaceflight. If there are any questions, I'll be happy to talk. I'll be happy to address them. Any questions about the new Artemis plans? Of course, there's a lot of things that we still don't know. There's words that the upgraded solid rocket boosters for Artemis have been canceled, for the SLS rather. But does that mean that the Block 1B SLS has been canceled? Maybe not, because Block 1B didn't rely on those upgraded solid rocket boosters. Instead, it had what was called the EUS, the Exploration Upper Stage, which had 4 engines on it instead of just 1. That really would improve SLS's heavy lift capability. However, if they don't do that and they just want to stick with basic plain Jane SLS rockets, there are a number of problems with that plan. Number one, you have to redo the launch tower. ML2 has a lot of that has been built now. I got to see the progress of it the last time I was at Cape Canaveral. A tremendous amount of progress has been made on ML2. And the problem is ML2 and the connections, the places where the launch tower, the fuel umbilicals and electronics, everything connects into the rocket, are set up for an SLS Block 1B, not for a basic SLS. So you'd have to redesign the launch tower. Okay, we are, they're waiting for a countdown. All of this, of course, is going to have copyrighted music, but last year was an incredible year for Rocket Lab. They had Electron launch after Electron launch. In addition to that, they secured some very, very valuable contracts, primarily in regards to building satellites, building spacecraft. 70% of their money does not come from launch. It actually comes from designing and manufacturing satellites and spacecraft and space technology. Electron is only about 30% of their revenue. Of course, they've been working on Neutron as well. Neutron is what Peter Beck hopes to be the flagship vehicle for Rocket Lab in the future. Their Falcon 9 competition, and maybe it will be, but it still has a ways to go. It's an incredibly sophisticated rocket. One of the most controversial things about it is the fact that it's almost entirely constructed out of printed fiber materials, carbon fiber materials, which is a very difficult thing to work with. And if you're going to make it reusable, it's very difficult to repair carbon fiber. If they ever have to repair carbon fiber on the boosters in order to make it reusable, that could prove to be very challenging indeed. I've spoken to other people in the launch provider arena, the rocket design arena, and many of them stayed away from carbon fiber specifically because of that. But on the positive side, carbon fiber is so lightweight that a relatively little rocket like Neutron is going to be able to deploy some very heavy payloads. The lighter your rocket, and especially the lighter your upper stage, the more payload you can deploy. And the second stage is going to be the lightest weight second stage ever built. So we'll see. In any event, let's go ahead and bring Rocket Lab back. So still waiting, hopefully, on a new T0. Fingers crossed. Yeah, man, Professor, you could modify it and repurpose it, but that might actually involve rebuilding the thing in many ways. I mean, Block 1B is fine. Block 1B, being a taller rocket, requires the umbilicals being in a different place and a different tower, just a totally different tower design. So, you know, it could be rebuilt and repurposed. Sure. Probably take time. It'll probably take money. And it might be very confusing too. It could create an engineering and construction nightmare, but they have to do it, damn it. They cannot continue to launch rockets off of the garbage ML1. That thing can never be fixed. Never. Because it was built by multiple contractors who didn't talk to one another. No one has a comprehensive design for the thing. Nobody has a comprehensive CAD drawing for the thing. Nobody really fully understands how it works because no one company built it. And the companies that did build it didn't talk to each other, which is one of the big reasons why this thing doesn't work. All of the hydrogen leaks that we've experienced in this recent Artemis 2 campaign has come from the ground systems in the launch tower, not from the SLS rocket. Yeah, very good point. Boosters, the Vulcan carbon fiber failed at the nozzle. Yeah, those solid rocket boosters, they've been having problems that they never used to have. Because the solid rocket boosters with the shuttle, you had that one O-ring thing. And again, O-rings, the O-ring failure happened exactly as designed. Exactly as designed. So, I don't know. It's the solid rocket boosters never really failed. They just launched the shuttle when they shouldn't have, when the engineers told them not to. So to go from these SRBs that were not only very successful, but also could be reused over and over and over again, to these SRBs that continue to blow their nozzles out, not only on Vulcan, the upgraded solid rocket booster tests for Artemis have had exploding nozzles as well. really strange how that's been going on. So I think in many ways, perhaps discontinuing that upgraded solid rocket booster might not be a bad idea. I don't think that Artemis is ever really going to need SLS Block 2 anyway. I think Block 1B is a good thing. I really think that's not a bad rocket to use into the future because it's not much different than the original SLS, but it has a huge increase in payload capability because of the EUS, the exploration upper stage. And another problem is if you're going to go back to just launching SLSs, if you say, okay, forget all this Block 1B crap, we're just going to keep launching the SLS as is, what that means is that United Launch Alliance is going to have to build more ICPS upper stages. In the original plan, the ICPS was only to be used on the first 3 flights, hence the term interim cryogenic propulsion stage. And it only had one RL-10 engine. Its capabilities for an upper stage engine are pretty pathetic. So the EUS exploration upper stage was always a very, very good upgrade because not only can it carry the Orion, it can carry about 12 tons of cargo with it. In other words, space station modules, perhaps supplies for a lunar base. There's a wide variety of things that all of that cargo could be used for. Something that Saturn V couldn't do, by the way. Saturn V could not send Apollo and all of that cargo out to the moon. The EUS has the potential to give SLS a big improvement in capability that still doesn't justify its ridiculous cost. But at the same time, at least it makes it better. So I'd be disappointed if they shut the whole thing down. And as I say, it will complicate things. It means they'll need a different ML2, Mobile Launch Tower 2, and ULA will have to start making more ICPS upper stages, which they weren't planning to do originally. And keep in mind, the helium issue that sent the SLS back to the vehicle assembly building, that happened with the ICPS. What are you going to do? So I'm not really sure if continuing to use the ICPS is the best idea anyway. Fingers crossed, guys. Fingers crossed. We'll see how all of this develops. But, the good news is I think it's a good idea to fix SLS, to make it into a rocket that can be manufactured more quickly, to make it a rocket that can be manufactured more affordably. I think that's a good thing. But how are we going to fix the HLS problem, the lunar lander problem, where neither Blue Origin nor SpaceX have a lander that has passed its preliminary design review, let alone its critical design review? It takes years from a critical design review to have a functional human-rated spacecraft. Even SpaceX hasn't been able to do it. So, I think that I'm concerned that the idea of landing on the moon in 2028 is still going to be an impossible task, not because of SLS, but because of HLS. But we'll see. Who knows? Again, if they can modify the Blue Moon Mark 1 into a human-rated craft that does not require refueling, they might be able to pull it off. It'll be disappointing for Artemis 3 to just be an orbital docking test rocket. That'll be a real bummer. There's nothing glamorous or spectacular about docking in Earth orbit, but it's necessary. Apollo had to do it, so why not Artemis? And that, I think, is what Jared Isaacman is telling us. We need to have more flights of this thing to stand a snowball's chance in hell of a successful lunar landing. We need to do things more like Apollo did them if we're going to have the slightest chance of success. It's a little late in the game to be doing things that way. And in my opinion, they're going to need more money to do it too. You're talking about redesigning and changing the SLS manufacturing system and trying to speed up the program and manufacturing 2 SLS rockets per year. Are you going to be able to do that on NASA's current budget? Not just no, but hell no. I don't see how they can. I really think that it's going to be necessary to go to Congress to get additional funding to make this happen. And so they should. If they really want to land on the moon, we talk about Apollo like it was this great accomplishment. And it was. It was an incredible accomplishment. But would they have been able to accomplish all of the things they did if they had less than half the money that the government gave them in the 60s and 70s? The answer to that question is no, absolutely not. By the way, that's one of the primary reasons that I'm the angry astronaut, is because NASA doesn't get the funding that they used to get in the 60s and early 70s, the funding that they need to go back to the moon. The other reason I'm angry is because there's 3 reasons I'm angry. The second reason is because when NASA does get money, oftentimes they misspend that money on corrupt contractors. The mobile launch tower is one of the biggest examples of how that money gets wasted. And the third reason I get angry is because of the narrow-minded point of view on the part of the scientific community and the media when it comes to UFOs and extraterrestrial civilizations, which, of course, is not what we're talking about today. Yeah, well, here's the problem with all that. And I agree, Matt. Here's the problem with what you're saying there, Matt Professor. How's Starship supposed to take people from the surface of the Earth to the moon? How's that supposed to be done? You launch them in a vehicle that has no abort system. You take them to orbit, refuel presumably, and you have a totally fueled up fuel depot, let's say. And then you fuel the thing up completely, go the rest of the way to the moon, land on the moon, great, lift off, come back, and then you need a good enough heat shield to survive a re-entry from a moon to Earth trajectory, which is 1,000 degrees hotter than a re-entry from low Earth orbit. Starship's heat shield has had a hard time with the temperatures experienced from low Earth orbit, let alone coming in from the moon. So I'm not saying Starship can never replace it. What I'm saying is that Starship is still many years away from being a complete replacement to SLS and Orion. As a New Zealander, you're not allowed to say Rocket Lab in Australia in the same sentence if they're launching from there, eventually launching from New Zealand's West Island. Yes, that's a good point. This is a collaboration between New Zealand and Australia, this launch. Australia has the payload and the hypersonic test article, and New Zealand has the rocket itself. And who would have imagined 15 years ago that we would be saying that you'd have a New Zealand company and an Australian company making this happen today? Very exciting indeed. And it's very true. A couple of people have said HLS has no heat shield. Very true. So that being the case, there has to be a multi-stage process to make all of this happen. And right now, the only vehicle that's capable of going to the moon, taking astronauts to lunar orbit, and bringing them back safely is Orion. And the only rocket that's capable of sending Orion to the moon is SLS at the moment. That could change someday, but it's unlikely to change before the early 2030s at the earliest. It's going to be a while before we get to that point. All right, we're still waiting. We still have copyrighted music playing. We are still waiting, hopefully, for an updated launch time. Fingers crossed. Come on. Up. All right, so we still don't have a countdown. Mike Lee, I'm going to tell you why that plan doesn't work either. The whole idea, they could meet with a Dragon on the way up. Let's say you put astronauts in the Starship, or no, you don't even put our astronauts in the Starship. You send Starship to orbit, you send a Dragon to orbit. You refuel Starship from the fuel depot in orbit, and then dock your Orion. Well, you dock the Dragon with Starship and put the astronauts onto Starship. Great. Then you send Starship all the way out to the moon, landed on the moon. Astronauts go out and do their thing for a while, a couple of weeks, maybe even a month, something along those lines. They reboard Starship, lift off, and come back. Starship absolutely will not have the delta V necessary to decelerate back into Earth orbit. It's impossible. They can't carry enough fuel to do it. And by the way, Apollo couldn't do it either. You need to use the atmosphere to slow you down. That's the only alternative that you have coming back. By the time unless somehow Starship refuels in lunar orbit or refuels on the moon or something along those lines, unless you can somehow work that into the process, which adds a lot of complexity, unless you can somehow do that, Starship will not have enough fuel left to slow down, decelerate into Earth orbit. It has to use the atmosphere to decelerate in the same way that Apollo did, in the same way that Orion does. It's very difficult to carry enough fuel for a round trip to the moon, from low Earth orbit all the way to the moon, land on the moon, lift off from the moon, go back into trans-Earth injection from the moon back to Earth, and then decelerate using your engines into Earth orbit. Can't be done, unfortunately. And so a lot of people have crunched these numbers on the delta V. It's just not doable. But yes, they could refuel in lunar orbit. That is a possibility. But man, you're adding a lot of steps then. You have to refuel it a bunch of times in low Earth orbit. You have to refuel it again all the way out at the moon. And how do you get all that fuel out to the moon? How do you transport it? You have to use another Starship. And that other Starship, assuming it's carrying, let's say it's carrying 100 tons of fuel, and probably needs more than that. But let's say you would need more than 100 tons, but let's say it was. You still need to refuel that tanker Starship 10 times and send it out to the moon to refuel. And as I say, 100 tons probably won't be enough. You're probably going to need 2 or 3 refueling missions at least, meaning you have 20 or 30 refueling missions in low Earth orbit in order to get the tanker all the way out there. Now, what Jeff Bezos has in mind, what he wants to do is utilize in situ resources on the moon to provide the necessary fuel. That's what he would like to do. So in other words, you use lunar ice to make hydrolox fuel. The problem is Starship doesn't run off of hydrolox. It runs off of methalox. It was designed for Mars, not the moon. There's no methane on the moon. Or if there is, there's very, very little. We've never found any. There's also very little carbon on the moon. So manufacturing methane using the Sabatier method on the moon is also very, very difficult. So the only way to get around that would be to have hydrolox engines on Starship's upper stage instead of the Raptors, which would be a huge redesign as well. So much complexity to all of this. It really is a pain. And again, ultimately, the problems will be solved. There's no question about that. Ultimately, Starship will become, in my opinion, a vehicle that can transport huge amounts of cargo and huge amounts of personnel to the lunar surface. But there's a lot of hurdles that need to be jumped, a lot of milestones to take Starship, not just from where it is now, but from the mature version of Starship that we have in mind for the near future to a Starship that's capable of doing all of the things that we would want it to do on the moon. Now, again, if Blue Origin can come up with an alternative design of some kind, utilizing in situ resources like lunar ice and hydrolox engines. Maybe they could do it. But right now, they don't have anything in the works that can do it either, because Blue Moon Mark 1, Blue Moon Mark 2, neither of them have a heat shield. And neither of them have the capability of, neither of them will have enough fuel to decelerate into Earth orbit either to transfer astronauts. It really is, this is an argument that Jim Bridenstine went through back in 2018, 2019, when he was being urged to abandon SLS and launch Orion using a different rocket, launch Orion using Falcon Heavy, or launching Orion using 2 Atlas V's or something along those lines. There were a lot of different alternative solutions that were less expensive than SLS, but every one of them have problems. Every one of them have a lot of complexity to make them happen. It's just very, very difficult to build a human-rated spacecraft that is capable of going to the moon, or to lunar orbit anyway, and come back and re-enter the atmosphere, bringing those astronauts back safely. It is a very, very difficult thing. So yeah. Fingers crossed, one day I'm sure it'll happen. But right now, Jared Isaacman's working with what we got. And I think it can all work. It's just a lot of problems that still need to be ironed out. Okay. We are still waiting for Rocket Lab to give us some sort of update. This could go for a while, guys. Unfortunately, it has been it's been a bit of an agonizing wait. By the way, don't forget to like and subscribe, guys. I'm seeing only 16 likes here. Maybe I'm seeing something wrong. I'm sure there's more likes than that. But please like, and if you haven't subscribed, please subscribe. It's super important. All right, we have 134 likes. Okay, I'm looking at an outdated version of the likes on the live stream. That's all. So I really appreciate that. If you have forgotten to like and subscribe, please do. By the way, I'm still happy to continue the conversation. I'm happy to answer any questions. And once again, I appreciate you guys being here. I appreciate all the super chats I've been getting thus far. It's been a very rough month, a very expensive month. I got lots of support, thank God, from generous supporters to bring my fantastic producer out to the United States. And of course, we didn't get to film Artemis lifting off. Go figure. But we did get a bunch of really cool footage in Houston and Cape Canaveral. So we're going to keep bringing that to you as time goes on. All right. So still waiting, obviously, on Rocket Lab. Feel free, of course, to ask me any questions you like. Once again, we're waiting on the HASTE vehicle to launch Hypersonics test article. This vehicle will not go to orbit. That's not the objective. The objective is to fly to suborbital space, about a 150-second flight. That's it. And then the test article will detach. It will theoretically engage its scram engines and maybe achieve hypersonic velocities. We'll see, but pretty exciting. And once again, the reason they're doing this, the reason Hypersonics is doing this, and as I mentioned before, I interviewed these folks in Colorado Springs at Space Symposium 2 years ago, and they're using Rocket Lab to get them up to hypersonic velocity with the HASTE vehicle. So their vehicle is essentially starting at hypersonic speed, and then also to get them up to suborbital space, to get them to an area where the atmosphere is still there, but very thin. And then they engage their own engines. So it's essentially taking a step out of the process. The Hypersonics test article doesn't have to achieve hypersonic velocity on its own. It can start at hypersonic velocity, and then it utilizes its own scramjet engines in order to maintain hypersonic speed. At least that's the idea. We don't know when liftoff's going to take place, just to be clear. Rocket Lab is waiting for high altitude winds to clear out, which is slowly but surely happening. Unfortunately, it looks like we have some cloud cover as well. So it's possible that that the HASTE vehicle, the hypersonic vehicle, is going to be above the cloud cover when separation takes place. So you probably won't be able to see the test article from the ground. So maybe, fingers crossed, hopefully, we'll have some cameras. Hopefully we'll be getting some details, because unlike every other launch of HASTE in the past from Rocket Lab, unlike all those other launches, this is not a military test. It is very, very exciting. It's the first, to my knowledge, the first ever hypersonic test of a commercial vehicle. And definitely the first one ever launched by Australia, or rather built by Australia. It's New Zealand that's launching it, technically. I mean, technically Rocket Lab is an American company, I mean, to make it totally technical. And it's also launching from an American launch facility. But I mean, let's be honest here. The vast majority of Rocket Lab's employees are Kiwis. Their founder is a New Zealander. So yeah, they base their company in the United States in order to get those great lucrative military contracts. The launch window continues for another 90 minutes. They have 2 hours from where the original launch window began, which was a little over 30 minutes ago. So they have approximately 88 minutes left in their current launch window before the FAA needs to close the skies. Very good point, Mike. So I appreciate you bringing that to our attention. And thanks, by the way, Mike, for being a loyal viewer for all this time. We have lots of loyal viewers here. Anton Nim has been with us for many, many years. There's a lot of folks here who have been here for a long time. Mad Professor has been watching me for quite some time. We have Aztec, who's going to be bringing us a camera feed from the Wallops Island area once we're close to liftoff again. So that's very exciting. So yeah, fingers crossed, fingers crossed. But we'll see what ends up happening. And by the way, if I seem under the weather, I apologize. I have been struggling with a disease that refuses to go away, and it takes on different forms from time to time. It's been quite frustrating. I've been to the doctor 3 times about this. Really don't know when it's eventually going to clear up, but hopefully it will. So if I seem a little under the weather, if it looks like I'm sleepy or something like that, I'm sorry. I haven't been sleeping very well lately. Thank you, Jack Morgan. Thank you so much for the $5 Australian. Really, really appreciate your support. And yes, a big moment for both New Zealand and Australia today. Let me tell you, there aren't too many countries that are building hypersonic space planes right now for commercial use. Not too many at all. And this company, Hypersonics in Australia, they're one of the first. And if they can make this work today, that's gonna catapult Australia into the big leagues, because that's a lot of capability. If you can get a hypersonic vehicle to work properly, that's a lot of capability and a lot of valuable contracts that you can capture with that sort of thing. Okay. So again, feel free to continue asking me any questions about either the changes to Artemis. In my opinion, the very desperately needed changes to Artemis. NASA has been talking about these changes for a long time, about reconfiguring Artemis 3 into a launch that does not require a moon landing. I think it's a good idea. I don't think that they're going to have enough flights under their belt in order to have a slightest chance of doing a relatively safe lunar landing with people on board. I think it'd be a very, very risky thing to do, to try to do that with Artemis 3. And so I'm relieved that they're going to do some more flights that don't involve a landing on the moon before they actually give it a shot. But the idea is to have 2 lunar landing attempts in 2028, presumably the first one being unmanned and the second one being manned. Again, I don't think that's very likely unless you're using the Blue Moon Mark 1, which is currently operational as a cargo lander, but a cargo lander that has a very big pressurized compartment. Pressurized compartment just means that theoretically it could support humans if it had an upgraded life support system. And keep in mind, Blue Moon Mark 1 is bigger than the Apollo LEM. So in theory, if Blue Origin's been working on this for a while, they might be able to make that work. But honestly, I don't see how they can do it in 2028 in any other way. Handheld nebulizer. No, I haven't, Mike. Need to keep that in mind. Thank you. Good idea. But, well, it'll help me in terms of breathing and that sort of thing. But, yeah, what I have is a condition on my lower tongue on my right-hand side. These lesions that won't go away. That's what's going on. That's part. And those symptoms kind of erupted immediately after a nasty flu. Usually that indicates some sort of virus in your mouth, but it's been there forever. And that gets worrying. You know, there's a wide variety of scary things that it can be, you know, if you have lesions that are there that don't go away. But then again, there's a wide variety of not scary things that it could be too. What I need to do is just get into a dental surgeon, an oral surgeon rather, and probably going to do that when I return to Britain. My doctor there is going to refer me to one anyway. Oh, thank you. All Things Space. Appreciate you watching every episode. Boy, I'll tell you, that's a lot of commitment because I put out a lot of episodes, a lot of episodes. All right. So let's see what else do we have? Oh, hey, Dave from Virginia Beach. Yeah, All Things Space. I think you were just talking to me. You may be able to see this thing fly too if you go outside at the right moment. Could be pretty cool. I mean, this is a small rocket, but you can see it from a considerable distance. I've seen an Electron launch once. And it was a neat flight. Can't complain. So once again, we're in this hold because of these high altitude winds. We are 38 minutes now into the launch window. Approximately 1 hour and 22 minutes remain. So it could be a while before they decide to go, because if this is a situation where the winds are gradually calming down, the wind speeds are gradually slowing down, and they're supposed to get better and better as the launch window goes on, then I would say it's likely that they're going to launch late in the launch window rather than earlier. Yes, man, Professor. I've done a couple episodes on that, actually. Lunar space elevator at Lagrange point 1 probably would make the most sense. Lagrange points are these solar system parking lots where the Earth's gravity and the moon's gravity cancel one another out. And you put a space elevator there. You put a space station there, first of all. And then you transport cargo, crew, etc., down a long carbon fiber cable to the surface of the moon on a climber, essentially. And that climber descends over the course of about a day to the surface of the moon with either passengers or cargo, and then it goes back up. The reason you do that is because you don't have to use the enormous amount of fuel that's necessary to land on the moon. Instead, you just rendezvous with the elevator, which takes way, way less fuel. If you did that, then yeah, that would open up a lot of possibilities. Indeed. Do I think Orbex should be bought out by another company? Yeah, although nobody seems to be interested. I think what's going to happen is Skyrora, the other major UK launch provider, is looking at grabbing up Orbex's technology and facilities rather than buying them as a complete company. But yeah, it's sad. Orbex going out of business, mainly because they didn't get the money that they were promised from the British government. There's about 70 million pounds that they were committed through the European Space Agency's Launcher Challenge, and then they just didn't get it. Now, according to the government, it's because they didn't raise enough of their own funds to qualify. That's what the government says. But the Germans and the Spanish companies have gotten way more money than 70 million pounds from their respective governments. And I can't help but wonder, did they really raise a couple €100 million worth of private funding before they got the government funding? Or did they get the government funding first and then the private companies invested once they knew the government was behind it? I don't know. In my opinion, I don't think Orbex was treated fairly. I really don't. And given how much progress they had obviously made on their first rocket, I think there's a very good chance. In fact, I definitely think that they would have made an orbital launch attempt this year had they received the funding that they were supposed to receive. Main danger of high winds, it can cope, but you want to test under ideal circumstances. You don't want wind conditions messing up your test. And again, also, you probably want as smooth of a disconnect between your booster stage and the hypersonic test article at high altitude as you can get, rather than it being turbulent. Turbulence could theoretically cause the test article to go off course, crash, whatever. So you want as calm of conditions as possible in these kinds of circumstances. I don't know if Artemis 2 will launch in April. If it does, I'll be there. All things space. We'll see. I think what'll happen, honestly, I think what's going to happen is they're going to take Artemis 2 back to they've already taken it back to the VAB. They'll fix that helium problem. Then they'll transport it back. Something will shake loose on the way. Something with a seal or something will go bad, and that'll be it. Yes, I have been talking a lot about NASA's new Artemis plans. I will be releasing a video about it tomorrow. It's going to be a little bit different than the videos that others have released. A lot of people are just going to essentially restate what Jared said, what Jared Isaacman said, maybe a little bit of interpretations and such. I'm going to talk about why a lot of it is good and a lot of it is still bad. Why it fixes some problems with Artemis, but it doesn't fix a lot of the most important problems. So, yes, that's true. Aero braking and aero capture are one way to do it, but again, you need a heat shield to do that. So it just adds more complexity. You probably want to get a lot of practice with aero braking and aero capture with the with Starship before you were to try to use that to enter into orbit. We've already seen sort of a modified aero capture process used by Orion. What Orion has been doing is that skipping that they've been doing off the atmosphere to take punishment off of the heat shield, which, you know, very good idea, I think. And even with that, however, the heat shield suffered. The heat shield went through suffered some damage. And I just, with a vehicle as huge as Starship, I don't know. I think it's going to take a while before Starship is going to have the heat shield that's going to work for interplanetary trajectories and the incredible speed involved in those trajectories versus a low Earth orbit reentry. Jared said one of his focuses to restart and complete NERVA. Very good idea. Definitely needs to be done. NERVA, for those of you who don't know, is nuclear thermal propulsion, which we worked on in the 60s and 70s. We did all of our ambitious space stuff back then instead of now. The idea is to channel hydrogen, as light of a fuel as you can get, and hydrogen, of course, is the lightest, through a very hot containment area, essentially. A containment area that's heated by a nuclear reactor. What happens then is the hydrogen is superheated by the heat of the nuclear reactor and then driven out of the nozzle of the rocket. And the speed that the propellant achieves under those conditions are at least double, maybe triple the speed of the exhaust of a conventional chemical rocket. What that means is you can either go twice as fast with the same fuel, or you can go the same speed with half the fuel. If you were to have NERVA, then you could definitely do that, as Matt or as Mike Lee is bringing up. If you're only using half the fuel, you could go to the moon and come back and enter Earth orbit, still have plenty of fuel to do that. Definitely a possibility. One of the problems are, of course, how do you land on the moon using nuclear engines? There's a lot of people that would have problems with that, with unleashing nuclear exhaust on the surface of the moon. You probably still need a separate lunar lander in order to accomplish that. So we shall see. We shall see. Yes, very true. NERVA is not classified anymore anyway. Might have been back in the day. If Artemis 2 launches in April, it'll be a night launch. Yes, it will. But later, if it launches more in May, it'll be a daytime launch. I think that's how it's gonna play out. You can see the colors changing on the rocket a bit as we get closer to sundown on the East Coast. As the sun sinks, these rockets take on a different appearance. That's definitely the case with Starship, by the way. I filmed and photographed Starship close to sundown and sunup at Boca Chica many times. It's beautiful, just beautiful. So, yeah. Very interesting. So, again, happy to answer questions. Again, we are still waiting for Rocket Lab to feel that the upper altitude winds are in a stable enough situation to where they can go ahead and lift off. Yeah, that's true, Mike Lee. You really can't. And so that's the thing with NERVA. I mean, some people have talked about using nuclear engines to take off from the moon and that sort of thing, but you're absolutely right. That's not what you use it for, in which case you still need chemical engines. So, here we go. Here we go, guys. We have Rocket Lab has resumed their countdown. 10, 16. Okay. I'm sorry, what? 14? Oh, 40 minutes? Okay. Yeah. Yep. We have a long ways to go, actually, guys, before this concludes. Let's see. Do you know the concept of aerobraking, Mrs. Mike, is based on skipping rocks on a body of water? Yeah. It's an interesting process, no question about it. And an interesting idea. So yeah, we're looking at 40 minutes to lift off at this point. So that means lift off at half past the hour. Yep. So we have a ways. Guys, I'm going to take a break at this point. I don't have the endurance that I usually do right now, still feeling a bit under the weather. So I'm going to take, honestly, about between 10 and 20 minutes off, just to get something to drink and just get my second wind and get ready for this liftoff. So we will, of course, keep the countdown going. We'll keep all the details coming to you. If there are any updates from Rocket Lab, we'll make sure that their volume is turned on. So hang in there for a bit, and I will be back shortly. office when I plan on being there. Can you go ahead, if I don't come back at that point, or if I'm not talking, yell into my ear because I might be asleep. Yes. Headphones are on the whole time. That's the thing, I can sleep through elevator music and call outs from the Rocket Lab team. I can sleep right through all that. All right, folks, here we go. Here we go again. Just under 14 minutes. Thank you, Mike Lee. Yeah, I have not been 100% well for a month and a half. We are now waiting. Happy to answer further questions, of course. Anything comes up. We have a little less than 13 minutes. Yeah, it's Russia and China definitely got the jump on the Western world for hypersonic missiles. Interesting, especially Russia. We've been seeing their hypersonic missiles in operation in Ukraine, a horrific place to be testing. Essentially, that's what they're doing, is testing them there on living targets. Just a horrible thing that's going on. Let's just hope that it ends at some point, but it really doesn't look like Putin's in any hurry to end it. I think he feels that he can probably just win it. I don't know. We'll see. Just all very ugly, especially since I have a friend there who's been a longtime supporter of the channel, a really lovely lady. Marina, she's just a lovely lady, and I hope that she's okay, because she's not with us today, and she's often with us during the live stream. But it is late at night in Ukraine right now. And for all we know, they could be going through another bombardment, as oftentimes happens at night there these days. Okay, folks. Let's hope this is good. This is going to be
Great
more
to have that done
spectacular
from
now
the
that
mission
it's
director.
happening
And
at night.
as the clock continues to count
And
down
a few
to
minutes
liftoff,
prior,
why don't we
if
take a
all
look at
goes
the rocket
well,
on the pad
our
for today's
steely-eyed missile man out in Virginia is going to try to film this for us as well
rocket with a
from
few key
his
differences.
vantage point.
This one is standing at 20 meters on the pad, and so HASTE is a couple of meters taller compared to a standard Electron, with a longer fairing that accommodates the DART aircraft that is on board. Also, since HASTE flies at lower altitudes, it runs a larger payload capacity of up to 700 kilograms, and its kick stage is tailored to the mission's precise conditions and tip-off requirements. Otherwise, from the stage 2 down, HASTE leverages much of the same technology that has powered our 80-plus Electron launches to date, and that includes the same carbon composite material used throughout its structures that keeps it lightweight and durable at both hypersonic and orbital velocities.
That's right, and HASTE also uses the same engine configuration as Electron, with 9 3D printed Rutherford engines at the bottom of the first stage that powers its flight. Now, the beauty of our liquid-fueled engines is their ability to gimbal and throttle, which opens up a variety of trajectories that our customers can test their technology with, much like today's mission.
By the way, Mad Professor, you're not wrong. You're right. The Lunar, there is no LEM to use as a lifeboat
Avionics
for the Artemis
sequence
mission,
61
but
checks.
we've been used to that
Copy
at
and work.
NASA for quite some time. Shuttle,
S-band to switch to high power for flight.
shuttle didn't have a lifeboat either.
LD on countdown.
Crew Dragon doesn't have a
LD stage.
lifeboat.
Stage proceed with the
So,
sequence 62
We've
stage
been doing
terminal
without
checks.
that for a while,
Copy and work.
but nevertheless, it would have been nice to have it. Yeah.
High voltage batteries are ready for flight.
GCLD on countdown.
How did you see?
GC proceed with sequence
We're in
63.
terminal count right now.
Launch pad ready.
Understood to work.
All pump lips nominal, all engines ready. LD stage countdown.
Stage LD.
That's the stage terminal checks complete.
Copy.
7.5 minutes and counting.
LD avionics on countdown.
Avionics LD.
Avionics terminal checks complete.
Copy avionics.
This should be spectacular, guys. Yeah, we'll see with HASTE. You're right. With scramjet engines, it's going to be hard to see it. But hopefully they got cameras on the thing. We shall see. But hopefully our cameraman in Maryland actually is where he is, just across from Wallops Island, approximately 45 kilometers away. He should be able to capture this launch on camera. We're under 6 minutes to lift off of the first test flight of Hypersonics test article aboard the HASTE Electron rocket.
Strong back projected for flight.
Electron has 9 engines, Rutherford engines, very, very tiny engines that run off of RP1 and oxygen, the old style rocket engines. Wow, man, Professor, I actually didn't know that. Interesting about Challenger. I'm actually doing some Patreon exclusive episodes about the shuttle. I just released my first one.
We are now at T-minus 4.5 minutes, and shortly we will have to enter the launch's countdown auto sequence, which starts at T-minus 2 minutes to liftoff.
Most people aren't.
That's when the rocket will switch to internal power and take over control autonomously. A few moments later, the rocket's LOX propellant loading should be complete and in recirculation.
Then again, at under 1 minute to liftoff, the propellant tanks, excuse me, will be fully pressurized for launch, and our ground controller will confirm that the water deluge system on the pad is ready to be activated for when those engines ignite. Then it is 30 seconds until launch before the LD starts to count down with the clock from T-minus 10 seconds. It's full noise at T-minus 3 seconds when those engines ignite, and then the launch pad's hold down mechanisms release for HASTE to take flight at T0.
We're going to bring up the audio channels now for Mission Control to listen along to those milestones in real time. We'll be back with you shortly after liftoff for those 2.5 minutes of hypersonic flight for That's Not a Knife. Go HASTE, go DIU, and go Hypersonics.
All right, folks. We're getting close. I'm not certain if we're going to get that extra camera or not. There are all kinds of things that need to happen internet-wise and elsewhere in other respects in order for us to see it. But
the count has been held. Hold.
So we are waiting, but it looks like we may get that camera just in time.
That is a hold on the countdown clock. We are paused.
Hi, Skywatch. I hope you're doing
2
well
minutes,
today.
56 seconds to lift off. So let's wait to hear for an update from Mission Control.
Confirmed.
And we're on hold.
GCLD on countdown.
How did you see?
GC confirmed the stage 1 and stage 2 umbilical status.
256 and another damn hold.
Copy, and please proceed with the secure LV on pad and enable ECS.
Understood work.
Thank you. Avionics LD on countdown.
LD avionics.
Avionics proceed with avionics terminal board checks sequence 73.
Copy and work.
Stage LD on countdown.
LD stage.
Stage proceed with stage terminal board checks sequence 74.
Copy and work.
Vehicles on external power.
I'd say the odds are very good we have a scrub now. We'll see, because there isn't a lot of time left in this launch window. So if they run into any problems, there's really no time to recycle the clock. If it's just because they need to check something real quick and then keep the count going from where it is right now, or to recycle it to 4 minutes or something like that, then it's possible. But if it's anything more complicated than that, then this is a scrub. There just isn't enough time, but we don't know yet. I've learned not to give up on these things until the fat lady sings. So let's see what happens. That's the way this stuff goes. We don't know if there's a launch or not, guys. We don't know what's going to happen yet. I would say odds are.
Copy, thank you.
Odds are there's going to be a scrub, but wait. Yeah. Odds are I'd say we're going to have a scrub, but I wouldn't say that 100%. I'd say 60%, 60, 65% scrub at this point.
Avionics terminal port checks complete.
But who knows? If there's a vehicle downrange, as somebody just mentioned, that you can clear out. You can clear the vehicle out and resume. Frustrating. But that is how this business works. By the way, this happens all the time in everyday life to Falcon 9 and everything. We just don't see it because nobody pays attention to live streams of boy, I'm telling you, that's how bad my brain is working these days. Whatever the heck, pardon? Whatever the heck satellite SpaceX launches. Starlink, thank you. Starlink satellites. Nobody watches those anymore. And this sort of thing happens all the time with them. So it's just part of the process. And we have to always have to make sure, especially with a customer as prominent as this one, the test as important as this one, need to make sure you got it right. And so that's why you have scrubs. Yeah, no, I don't have anything to say about 3i Atlas right now. It's not a lot of new news. There's a picture was released by the Juice Probe, ESA Juice Probe of 3i Atlas. And it showed us a lot of the same things that we saw on the same date from other telescopes. Definitely had a tail pointing in the right direction for those particular photos. In my mind, that creates more questions because if you had a tail behaving properly at that moment, that means you have to have microscopic ionized particles being created by outgassing, by cometary outgassing. If that's the case, then why did those microscopic particles just magically go away? Because later on, all the photos that were taken by Hubble, by James Webb, and other images taken of 3i Atlas a month and a half later were showing a prominent anti-tail and no conventional tail at all, none, which was very similar to the way it was months prior to perihelion. How is that possible? If outgassing was creating microscopic ionized particles at one point, then what happened to all that stuff later on? Why do we only have an anti-tail and no conventional tail right now? This is a weird object and nobody acknowledges that. It's really frustrating. They just reset to 26 minutes. My God.
At the top left-hand corner of the screen has restarted, counting down to the final opportunity in today's launch window. We are, however, still waiting to hear the confirmed new T0 time from the launch director. So we're keeping up the audio channels from Mission Control, waiting to hear that call from her hopefully soon.
Right. Yeah, this is not a real countdown, just to be clear, folks. This is a countdown to the end of the launch window.
TCLD.
We secured the pad, ECS is new.
Yeah, generally that means we have a scrub upcoming. But we'll see. But yes, I would say that a scrub is looking very likely now. Not 100%, but likely. Sure. Not a bad idea, Matt Professor. Not a bad idea. Yeah, it is in March. I don't know the exact date as to when it makes its closest approach to Jupiter. That is going to be an important day. Oh, the disclosure. Yeah, I'll tell you, Skywatch. And I think if I understand correctly, it's Trump saying that he's going to instruct the Pentagon to release information or whatever. I've seen nothing. It's been a week now since he said that. And Arrow hasn't posted anything at all since January. Nothing. Does that mean that it might come through somewhere else? I guess, maybe. But all I can say is I'll believe it when I see it. Anytime you get anything from anyone about how, we're gonna go ahead and lift the veil on UFOs. I think they might lift the veil on the ones that they have mundane explanations for, and then they'll continue to hide the other ones. That would be my guess as to what's going to happen here. Show us a bunch more, say, oh, well, we have this one, and this is what it was, and we had this case, and that's what this one was, and they're not going to tell us anything else. We'll see. Maybe I'm wrong, but I'm very cynical when it comes to these kinds of things. All right. Interesting. I'll have to look that up about Tim Phillips. I hadn't heard that, but you Skywatch, you have your finger on the pulse of this stuff more so than I do. My channel is still, most of the content I reveal is still spaceflight and space science related.
Targeting end of the window.
It gets 50-50 sometimes.
column 00, column 00 UTC time.
It's still
now
a majority
on the 28th
spaceflight.
of February. And all operators continue monitoring your critical systems and be prepared for the go, no go, and starting the count at T-minus 60 minutes as usual. And I confirm that I'm actively monitoring countdown cord, LV cord, range cord, and safety net.
Okay, just backing up what we heard from our launch director there for the new T0 time for today's launch attempt. We are now targeting 7 p.m. local time Eastern, which is 0000 UTC for today's opportunity.
My God, they're going to do it. They are still shooting for that time frame. We're just over 20 minutes away now. Here we go again. Oh my God. I wonder what caused that pause. Maybe there was a vehicle downrange or a boat or something. This sort of stuff happens. Just so you know, though, guys, and even my producer doesn't know this yet, I am planning on having an all UFO live stream here soon. Jenaded has kindly allowed me to use some of his latest stuff that he has on his Patreon site to do a live stream. So you're going to be seeing some UFO footage that you may not have ever seen before on this live stream. So I'm very excited about that. So it's interesting that they are actually targeting this. That is weird. They're targeting the very end of the launch window, which is just under 20 minutes away now. That's strange. Again, that's usually you get a scrub rather than attempting to do that. But maybe that's what they're shooting for. But at this stage, anything else comes up and is absolutely, definitely a scrub. Yeah, I don't know, Mike. I mean, if they're going to scrub, why not just say it? I really think that they may have, who knows, they may have a few minutes of flexibility in the window or something like that. If they were done with this, they just go. They just scrub. So they wouldn't bring up a new T0. Could be, Mike Lee. Maybe they are just going to test something prior to launch, or they might have intended to launch it first, and now they're just going to go ahead and run through some testing procedures before they scrub officially. But yeah, they actually have the launch scheduled for exactly the moment that the FAA launch window expires. And by the way, if you're talking, well, no, actually, there's a lot of air traffic at this time of day in the East Coast. Oh, we're putting it on. Yeah, we don't have the camera live yet. We're going to bring it. We're going to bring that camera live from our friend Aztec. There's a naval air station that he's going to show us. It's in the same area. So producer, I trust we didn't hear that, right? The viewers didn't hear that. What this is this air station had to absorb a lot of other air bases during the drawdown when there was a reduction in bases after the Cold War, and this became a very, very large air base as a result. So that's what we're looking at.
All right, we are at T-minus 16 minutes and 30 seconds, heading towards the final go, no-go poll for the last opportunity today. We are currently looking green across the board, pending confirmation from the mission director that the customer is go, then we'll be proceeding through to T0. Over to mission control now.
Looks like they're going to give this a shot. So apparently this
Mission
airbase,
Delta,
Tom Clancy
countdown proceeding
refers
with the
to it
final
in
pole
a
for
sort
launch
of
go,
a
no
vague
go
way
sequence, starting with
in
the
a
stage.
number of his novels.
Stage is go.
There's apparently
Avionics.
also a
Avionics is go.
secret quote unquote
GMC.
sub base there. There are nuclear weapons
GMC's
at
go.
this facility.
Beacon.
So
Beacon is
there's a
go.
lot of stuff, a lot of
GC.
military operations
is
in
go.
this region.
PLS.
PLS is go.
Mars CE.
Mars CE is go.
Mars Ops.
Mars Ops is go.
Mars 1.
Mars 1 is go.
NASA GSO.
Go.
NASA RSO.
Those go.
NASA PM.
Go.
LD SUP.
LD sub is go.
NASA TD.
Go.
Copy, all standing by for go for the mission, Director Paul.
Excellent news out of Mission Control. The local
go
and
from everybody
support teams
except Mission
are
Director.
go for launch,
Here
and
we
we are
go.
proceeding through the count. A
Take
reminder
another
that
shot at
today's
this.
T0 is now set for 7 p.m. Eastern Time or 0000 UTC. We've got about 14 and a half minutes remaining in the count.
If this goes, it'll be amazing. They'll consume every last second of the launch window, which would be pretty interesting. Frustrating, but if it works, hey, let's go, guys. Let's light this candle. We're closing in on terminal count again. Come on, baby. Let's do this. Da, da, da. 12 and a half minutes at this point. Closing in on terminal count again. Yep, I feel like it. I feel like it'll go. It's at 7 p.m. Eastern too, midnight UK time, 5 p.m. here in Colorado Springs. Eternal, I'm releasing a video about what Jared Isaacman said. I said a number of things about it today. Let's say there's good stuff and bad stuff. Good stuff for SLS, in my opinion, in making it more useful than it is right now, but unrealistic stuff when it comes to landing on the moon.
On countdown, ready to proceed with the go-no-go poll.
Copy,
But I will definitely have a video on that topic
MD, go
tomorrow.
For terminal count.
Copy, the go-no-go sequence is now complete. We are T-minus 11 minutes, 18 seconds and counting. This time we are go for terminal count starting at T-minus 10 minutes.
That's the last confirmation we needed from the mission director and mission
to
management.
go into
we
terminal
are
count
go to
again.
proceed towards liftoff.
Let's go, baby. Here we go, guys. We actually have a go for launch from the mission director. Wow, it'll be something else if they get this thing off the ground right at the end of the launch window. Mad Professor, China's winning the race. China is winning the race because they're not having to replan, redo, make changes to Artemis, that sort of thing.
All right.
That
Well,
Jared
while
is
we
doing
have a little bit more time to wait, we did
Isaac
hear earlier in the
desperately
show
needs to
from
do
our
that.
range coordinator David Stiles
China
about
had a good
busy
plan to
operations
begin with.
at Launch
They
Complex
have a
3
good
right next
rocket.
door
They
for
have a
our
good
new
lunar
medium lift
lander,
rocket
as far as
Neutron.
we know.
And last month, hardware began flowing to the launch site, starting with the reusable Hungry Hippo fairing. So let's check it out.
We got music. Let's see. Yeah, music. Oh, well. So the Hungry Hippo is a unique, just a unique feature on a rocket, because usually you have fairings that fall away. Even SpaceX does on the Falcon 9. And so they have to try to retrieve those fairings, which they've gotten very good at doing. But the Neutron fairing opens up like a hippo's jaws to let the second stage out. Because of that, since you have a fairing that is connected to the first stage, to the booster, rather than part of the second stage, that reuses the fairing and the booster all in one, first of all. Secondly, it reduces the weight of the second stage dramatically. Lot of positive changes, assuming it works.
Stage LD on countdown.
LD stage.
Stage proceed with sequence 62, stage terminal checks.
Copy it, Mike.
GC LD on countdown.
LDGC.
Proceed with sequence 63, launch pad ready.
Understood, launch pad ready, work.
All pump lips nominal, all engines ready. LD stage countdown.
Stage LD.
That's the stage terminal checks complete.
Copy stage.
LD avionics on countdown.
Avionics LD.
Avionics terminal checks complete.
Copy, thank you.
Yes. Me neither. Yeah, Mad Professor, if Constellation had gone forward as planned, we would have been on the moon a long time ago. Oh, camera view. Sorry about that. Obviously, you have me in the top left. You have the Electron rocket preparing to carry the Hypersonics test article up to suborbital space, where it will detach and engage its scramjet engines to take it on, hopefully, a really high-speed journey through the upper atmosphere. And then at the top right, you have one of our awesome team members who just happened to be in the area. He's approximately 45 kilometers away from the launch site, and he's doing his best to give us a view of the rocket as it takes off. We'll probably be able to see something at nighttime, even at that distance, let me tell you. So we're getting close, guys, but we've gotten this close before. But we are getting very close.
Hold down mechanisms armed.
T-minus 4 minutes and 50 seconds,
Chaser,
and shortly we are nearing terminal count, scheduled to start at T-minus 2 minutes.
Mini space shuttle.
That will kick off a series of events for HASTE, making sure its fuel and oxidizer tanks are pressurized and ready for launch, and activating the final ground system, the Deluge.
We're close.
The Deluge is dual purpose. It obviously keeps things nice and cool, but is also imperative for sound suppression, keeping our 9 Rutherford engines considerably quieter.
That's right. And then we will hear a 30-second call out followed by the final 10-second countdown from the launch director and mission control ahead of engine start at T-minus 3 seconds. So let's throw it back to the team in mission control for the final moments ahead of liftoff, and we will be back with you once we are in flight.
ECS disabled, pad auto sequences armed, pad is ready for launch.
Thank you, Jesse.
We'll see. Man, this might just happen. About 3 minutes 30. Rocket Lab has one more shot at this tonight. If anything goes wrong, it's the end of the launch window and it's game over. But if they can pull this off here, it'll be pretty cool.
And all stations, we are T-minus 3 minutes and counting. At this time, the 3-goal procedure is in effect. From now on, there should be no red flags in your critical LCCs. VCON, LD on countdown.
LD VCON.
VCON, log the auto sequence and confirm.
Locked.
And confirm VCON, all flight computer ASGOs are green.
All ASGOs are green.
Thank you, VCON. We'll go for auto sequence start T-minus 2 minutes.
3 minutes now, guys.
At this time, LDs go for launch.
Less than 2 minutes.
The vehicle is fully on internal power. RF reception is nominal, and AFTS is green and enabled for flight.
Here we go, guys. Come on. We're on auto sequence now, guys. Rocket is in control.
Lock load is complete. System is in recirculation.
About ready to go there. Very close to launch, Aztec. Thank you.
Anti-geysering is disabled.
One minute. Godspeed, Rocket Lab Haste. Godspeed, Hypersonics. Let's go.
Stage 1 tanks are pressed.
High flow engine purge enabled.
T-minus 20 seconds and counting.
Stage 2 tanks are pressed.
Stage activated.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition.
Here we go.
Liftoff.
Vehicles split pad, vehicles pad.
There we go. Spectacular. There we go. Electron haste is airborne. Magnificent. Just about to vanish into the clouds at this point.
Well, that's not a knife. That is our Haste rocket on your screen there with a textbook launch off the pad at LC2 on Wallops Island. Haste is climbing fast now at almost 900 kilometers an hour with an almost immediate pitch over to follow today's suborbital trajectory. Max Q, or maximum aerodynamic pressure, is up next. So standing by now with mission control.
Approaching max Q. Cleared max Q.
A nice clean sail through max Q by Haste there, now at speeds of more than 2,000 kilometers an hour. Hearing good calls from mission control as well. High voltage battery discharge should be happening as we need it to for those 9 stage 1 Rutherford engines at the bottom of the rocket. And coming up soon will be MECO, or main engine cutoff of those engines, which is when all 9 of them power down at the same time. And now usually that is to allow for the first stage to separate from the second. But with this experimental hypersonic mission, we are doing things differently. And so at about the same time as those engines shut down, Haste's fairing will separate and DART will be deployed to begin its free flight at hypersonic speed.
A reminder that at our customer's request, we'll be cutting the camera view just before MECO, fairing separation and payload deployment, but we will mark the moments we're expecting those actions to take place before DART AE flies the rest of the mission. So let's watch and listen now.
Stand by for MECO.
It may have frozen. It may have been frozen. I don't know what happened, but in any event. Beautiful, beautiful flight on the part of Electron Haste. No problems so far, as near as we can tell. This is not a long flight at all. There should be main engine cutoff coming up very soon if it hasn't already happened.
Okay, and with the clock now past 2 minutes and 45 seconds into flight, that marks our expected main engine cutoff,
Showing mission control at this
jettison
point.
from Haste, and deployment of Hypersonics DART AE aircraft at hypersonic speed to continue on with their mission.
Right now, the team will be testing the aircraft's aerodynamic control at several times the speed of sound, as well as its scramjet propulsion to power the vehicle along its suborbital trajectory. Good luck to the DIU and Hypersonics for the remainder of the mission.
So Haste's role in this launch is otherwise complete. Another hypersonic test launch with 100% mission success out of Launch Complex 2 on Wallops Island.
They cut
and this
off
is our
the
second
camera
hypersonic flight for the
prior to
DIU
main
in
engine
just
cutoff
3
and
months.
the
And our 7th Haste launch
ignition
overall
of
to test
the
technology in those
hypersonic
real-life
test article,
conditions.
presumably
This mission
because
is
they
also
don't
our
want
11th
people to
overall
see it.
launch from Launch Complex 2 on Wallops Island within both the Mid-Atlantic Regional Spaceport and NASA's Wallops Flight Facility. So, congratulations and thank you to our launch partners for your ongoing support.
And since we're rounding out with numbers, today's launch is our 82nd launch in total and 3rd launch this year, with our next mission scheduled to take place in just a few days' time. But this time from Launch Complex 1 on the opposite side of the world. Make sure you check out our social pages and
any
website
further
for more
information.
info.
Let's go ahead and cut them
Otherwise,
off.
thank you so much for joining.
At this point, producer. And we're going to go ahead and I'm going to see if we have any more information about what happened with the main engine cutoff, separation, etc. See if anything else was announced. Nope, nothing yet. So unfortunately, we didn't even get to see the main engine cutoff, because that's exactly when the fairing would have separated and all that. It's very possible that that particular moment is also something that Rocket Lab has proprietary with their own, with the Haste version of Electron. I don't know. In any event, what I was hoping wouldn't happen, and these folks not showing us anything, apparently has happened. Nevertheless, near as we could tell, this went perfectly well. And I can't say that once again, I can't say that it was unexciting to see this amazing liftoff at night. This glorious, beautiful liftoff after sundown, which wasn't supposed to happen originally. So I'm going to keep all of you guys up to date as to what happened with the test article. Hopefully there'll be something that we get, but no, it's not military classified, to answer your question, Mad Professor. So the only reason that they would have done, well, there's 2 reasons they would have done it. Number one, because Hypersonics doesn't want anybody to actually see their test article in action. They don't want people to learn anything from it. Or number 2, or they don't want their competitors to learn anything about it. Number 2, it could be that when Haste separates its fairing and has all of those things happen with main engine cutoff, there could be things about the Haste rocket that are military proprietary, since this thing is usually used for military flights. So for what it's worth, I'm sorry about that, but at least we got to see a pretty impressive nighttime liftoff. That was an unexpected benefit. Happy for that. Thanks so much to all of the team, to Aztec for your camera work efforts out in Maryland, and of course to our fantastic producer. Please don't forget to like and subscribe, and stay tuned, because I've got more content coming for you very, very soon. Until next time, stay angry about space.